Now that our preparations are complete, we can use the Haas intuitive programming system to set up our jaw boring operation. We start at the ID Turn tab. We'll be using Tool 1 and work offset 54. We leave Z starting point set to 0, so our boring cycle will start at the face of the jaws, where we set our G54 offset. We set inside diameter to 2.2 inches, just clear of where the insert will start cutting. Our part's nominal outside diameter is 3.950, so we set diameter to cut to 3.95 inches. Cutting our bore to 1 inch deep will give us more than 1/3 part length grip. We set the remaining values conservatively based on the insert we're using to cut these steel jaws. When boring, OD gripping soft jaws cut the inside diameter of the jaws to the nominal workpiece diameter. In our case, the blueprint shows a diameter of 3.950, and so we will bore to the size of 3.950 inches. This graphic illustrates what would happen if you did not cut the nominal part diameter. Undersized jaws will grip along 6 edges, whereas oversized jaws will grip only along the center of each jaw. Our program is set to cut at the nominal part diameter. The soft jaws are clamping inwards on the boring ring at 100 psi, which matches the direction and pressure we'll use when cutting the parts. The master jaws are at the center of their stroke. Now we're ready to cut these jaws. Once the jaws have been cut, make a shallow groove at the bottom of the jaws. Any workpiece with sharp edges will now locate correctly against the jaw's back face. Without this groove cut, a sharp-edged part will not locate correctly on the back face. You will likely need to deburr the jaws when the machining is complete. Now that they have been bored, grooved, and deburred, these jaws are ready for use. In some cases, you won't be able to use the adjustable boring ring because the part diameter is so large that the ring itself will block your cutting path. That's exactly the case with this part here. In this case, since we can't use a boring ring, consider using a plug of material to hold the jaws in position. Before profiling the jaws, we will take a small cut on the inside diameter of the jaws equal to the plug diameter. We will use the adjustable boring ring again to hold the jaws while making this initial bore. We check the plug diameter and enter it into the IPS diameter to cut field. Boring the jaws this way will hold the plug in the best possible manner. One of the important benefits of using the plug is that you can exert full desired clamping force on the jaws. You can eliminate the need to add a taper to the jaws by matching high jaw cutting pressure to high workpiece cutting pressure. With the bore for our plug complete, we clamp it at the center of the jaws, leaving adequate clearance for the cutting path. We apply the clamping force to the plug in the same direction and pressure that will be used on the workpiece, which in this case is 250 psi. Before cutting these jaws, Andrew notes that unlike our previous part, the finish on this material is very rough. Despite this variation, in our case, we will still cut the pocket to hold the raw stock at the nominal stock diameter. Realizing that in some cases, we will be holding at the 6 edges of the jaws, and other times at the 3 centers. Now, we will be making 2-step jaws for this part, and with our program set to cut both pockets to the nominal size, we are ready to cut our jaws. Two-step jaws are a good alternative to cutting 2 different jaw sets. When part geometry is favorable, the larger pocket holds the uncut raw stock, while the smaller pocket holds the half-finished part for the second operation. With these two-step jaws cut and grooved as before, we are ready to start making parts. Thank you for watching. Be sure to check out our other soft jaw videos where we cover the essentials of ID gripping and other topics including adding tapers and recutting your jaws.